Okay, hello year 11 extension 1. What I'm going to do here is I'm going to go through some more polynomial division examples, and just before I do that, I'm going to actually draw some few more analogies from when we do normal long division with just regular numbers to hopefully make it a little bit more clear if it wasn't super clear in class. I am not putting on my webcam. I tested it. My neck shows too much and I am too vain for this. So let's get started on this example. So here I have an example of just normal long division that you might have seen when you were in year 6 or in year 7. So we have 324 divided by 11. And so hopefully you're pretty okay with this notation. What I'm going to do is I'm going to write 324 and I'm going to divide it by 11 here. So just a reminder, 324, that's our dividend, that's our number that we're dividing, and we're dividing it by 11, our divisor. Now, what we did here was we actually just started looking at my 324, and I broke it up into different digits. So we start by looking at the first digit, and if it doesn't work, we look at the first two digits, and we keep going down until I find a number that can be divided by my 11. So here, that's similar to us looking at our leading term of our dividend and dividing it by the leading term of our divisor. We're trying to look for how many times does my divisor, so for example my 11, go into my dividend. But here it's a little bit different with the numbers. So here, let's do that. Does 11 go into 3? No. So I'm going to actually look at the next digit. Does 11 go into 32? Yes. It goes into it twice and gives me 22. Then once I did that, what I do is I subtract, and I think everyone was pretty good with this step. We subtract the two together and we get 10 left over. Once I've done that, I'm going to draw down the 4 and get 104, and I repeat this process. I start from the front. Well, 11 doesn't go into 10, so I'm going to have a look at 104. How many times does 11 go into 104? I know that it goes into it 9 times because 99 is 11 times 9. And once again, I subtract, I get 5. Now, if you were continuing this, you could do it into decimal places, but I'm just going to stop here. But what I've got here is that I've got 29 remainder 5. And so what I can do is then I can summarize this as writing it as 324 is equal to 11 times 29 plus 5. And so we did this similarly when we had a look at that division notation, that division theorem, where we could say, oh, a polynomial can be written as our divisor polynomial times the quotient polynomial, the number that we multiplied that divisor by to get that polynomial, plus a remainder. And so that's what is similar to when we do normal division, regular long division and polynomial long division. So what I'm going to do is I'm going to have a go at 2 examples with you in this video. So let's have a look at this first one. What I have is x to the power 4 minus 3x cubed plus x squared minus 7x plus 3 in blue. Now just a reminder, this is called the dividend. It's a polynomial that is being divided. And I'm dividing that by x squared minus 4x plus 2. And that, if you remember, is your divisor. It's the number that you're dividing, or the polynomial in this case that we are dividing, divisor. Okay. Now what I said in class, the mistake that I made at the start was I need to check that I have all the consecutive powers of x here. So let's check the dividend. I start from the left, so I've got x to the power 4, I've got x to the power 3, x to the power 2, 1, and this 3 is technically x to the power 0, so I have all my consecutive powers. Tick, 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 tick. All good, so I do not need to leave any gaps here. Let's check the divisor. I've got x squared, x to the power 1, x to the power 0, I don't need. And so I've got all my powers here, all tick, 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 tick. So what I'm going to do is I'm going to write this with division notation. So I'm going to have x squared minus 4x plus 2, and I'm dividing my polynomial by this. I'm dividing x to the power 4 minus 3x cubed plus x squared minus 7x plus 3. Okay, cool. So what I did here was, instead of having, so when I did my regular long division, I kept going down the digits until I had a number that I could divide in my dividend by my divisor. Here, what I'm looking for is I'm looking at the leading term of my divisor. I'm going to highlight that in purple. I'm going to look at the leading term in my divisor. So my leading term in my divisor is my x squared term. So this is my leading term. I'm going to put that in green. And I'm going to look into my dividend, so the blue term. I'm going to have a look at the leading term of whatever's left in there and figure out how many times does my leading term of my divisor, so leading term divisor, how many times does it go into the leading term of my dividend? Well, if you have a look, I've got x to the power 4 in my dividend, so the blue. I've got x squared in my divisor. How many times does it go in there? Well, it goes in there x squared times. So how you can do this, just if you're not too clear, you can go x. If I divided x squared, the leading term of my divisor, I end up getting x squared. And so that's how I get that term in my quotient or in the green. So I've got x squared. Now that I've done that, what do I need to do? Well, when I did it with my regular division, up here, I multiplied this number with my divisor, and I got this result down here. I'm going to do the exact same thing. I'm going to multiply my number in my quotient by not just my leading term, but my whole divisor. I'm going to multiply that with my whole divisor. So let me do that. I'm going to have x to the power 4 when I multiply by x squared minus 4x cubed when I multiply my x squared with this 4x. And then I'm going to have plus 2x squared when I multiply that 2 with my x squared. So I've got this when I multiply x squared with my whole divisor here. Okay, I've got that. Now that I've done that, I need to subtract the 2. When I subtract the 2, my leading terms hopefully will cancel out. It should always cancel out. So these two will cancel out. Then I've got the next term. I've got negative 3x cubed minus negative 4x cubed. When I subtract the 2, I'm going to just be left with x cubed. And I'm going to repeat that with my x squared term. So here I'm going to have x squared minus 2x squared. So here it's going to be minus x squared. Okay, now that I've done that, I'm just going to do the exact same thing I did with when I did regular long division with numbers. I'm going to drop down my next digit, or in this case, when I'm doing it with polynomials, I'm going to drag down my next term in my polynomial, 7x. Okay, cool. Let's have a look. Well, how many times does my leading term in my divisor, my x squared, go into the leading term in my dividend, or the remainder of my dividend? Well, x cubed divided by x squared will just give me x. So I'm going to have here plus x. And so I'm going to multiply this positive x into my divisor. So what do I get? I'm going to have x cubed when I multiply x squared by x. Then I'm going to have minus 4x squared when I multiply negative 4x squared, 4x by x, plus 2x when I multiply this positive 2 by x. And so that's how we get that next part here. Okay. So once I've done that, I subtract again, and I think everyone was cool with this step. I subtract. The x cubed terms will cancel. Then I'm going to have negative x squared minus 4x squared. Negative x squared minus 4x squared will just give me 3x squared. And I'll have negative 7x minus 2x, so that will give me negative 9x. Okay. Now, like I did before, I'm going to drag down my next term. So here it's going to be that plus 3. I'm going to drag down to here, plus 3. And again, I repeat that process. I look at the leading term in what's left in my dividend. My dividend leading term is 3x squared. 3x squared divided by the leading term of my divisor, x squared, would just be plus 3. And so I multiply plus 3 with my whole divisor. So here I'm going to have 3x squared minus 12x plus 6. And so once I've done that, I'm going to subtract the 2. When I subtract the 2, my x squared terms will cancel. Negative 9x minus negative 12x will give me 3x. And I've got 3 minus 6, which will give me negative 3. At this point, I can check. Okay, I'm going to have a look. Can I divide 3x minus 3 by x squared minus 4x plus 2, my divisor? Well, no. If you have a look, my leading term is x squared, and the degree of that is 2. My dividend, what I have left is 3x minus 3. The degree of that is 1. And so I can't divide that any further. So at this point, I am done. And I'm going to actually just write it on the side here to summarize what I've done. So therefore, I'm going to write it in the form that we had before. Px is equal to dx, my divisor, times my quotient, qx, plus my remainder x. I'm going to rewrite this result here with this notation. So let's have a go at that. So my polynomial that I started off with. Was the blue thing. X to the power 4 minus 3x cubed plus x squared minus 7x plus 3. That's equal to my divisor. Well, what was my divisor? X squared minus 4x plus 2, my purple polynomial. X squared minus 4x plus 2, and put a bracket around that, times my quotient. What was the quotient? Well, it was the number that I got at the top in green, which came as a result of doing this division, times x squared plus x plus 3. That was this result up here in green. I'm going to color code this in a second. And what do I have to add on top of that? Well, I have to add my remainder, plus my remainder. What was my remainder? The thing at the end, 3x plus 3. So what I have here is my p of x, my polynomial that I started off with, x to the power 4 minus 3x cubed plus x squared minus 7x plus 3 is a result of the product of my divisor. My divisor was the purple term that I had at the beginning, x squared minus 4x plus 2, times by my quotient, the result that I had at the top, so x squared plus x plus 3, plus my remainder. And I'll just color code this red or yellow for the sake of it. Okay, so that was this first example here. Hopefully that made a little bit more sense. I'm going to have a go at another example in a second, but hopefully that was a little bit more clear. If you have any further questions, please post it in the Google Classroom or on this video.